Hello everyone, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to cover in this short lesson is how to set up a hardware counter. Now the hardware counters and the hardware timers are linked, so what I'm going to do is I'm just going to pop over here to the data sheet for a moment, and I'm going to look at the timer 0 module, which you've looked at before. You've looked up the details of it. What you notice about the timer 0 module is that it can be both a timer and a counter. We're going to use it today as a counter. Now this is an 8-bit counter, so it can't count any higher than 255, so do be aware of that. If it does, it'll overflow obviously, and it'll start counting again from 0, so you may get your number incorrect if you allow it to count to a higher number than 255. Now, it's important to just look again at some of the detail here in order to determine how we set it up as a counter. So what changes with regard to dealing with it as a counter rather than a timer. So one of the things we see up here, obviously I've done a search for counter, and be wary of doing that, by the way, because there are a lot of other types of counters in here. There's a program counter, and there's a counter to do with the watchdog timer as well, and they come up a lot, so it takes you quite a while to get to here. So you're far better doing a search for timer first to get yourself to timer 0, and then once you're there you can do a search for counter, and you can see all the different instances of counter written on the screen here. Counter mode, as we can see up here up in this section, counter mode is selected by setting bit T0CS. So by setting the bit, obviously what we mean by that is by putting it to a value of 1. So do try and get used to that. That sort of terminology where if you set a bit, you're putting it to a value 1. If you clear a bit, you're putting it to a value 0. You can also call that resetting it to a value of 0. We often, and I often do it myself, make the mistake of saying setting something to 0. I shouldn't really do that. I should try and stick to setting it to 1, clearing it to 0, because otherwise a little bit of confusion can take place. You'll see here that they haven't actually said putting it to a value of 1, they just said setting the bit. So it's important that you get used to that terminology, meaning that the bit goes to a value of 1. So to put it into counter mode, we set T0CS and we put that to a value of 1 to set it. Okay, so note that down as regards how to do it, because we've used that T0CS before, but we reset it or cleared it to a value of 0 in order to make sure that it was used as a timer. In counter mode, timer 0 will increment either on every rising or falling edge of pin RA4. Now RA4 obviously is the one of the port pins of port A. So clearly what we're going to do is we're going to have an input coming in on RA4, and we're going to count how many times either a rising edge occurs or a falling edge occurs. For our first application here, we're not even going to concern ourselves with whether it's a rising or a falling edge. We're just going to count the number of instances of it that take place. Now I have a feeling that it probably defaults to a rising edge if we don't actually set it to one or the other. We can see here the incrementing edge is determined by the timer 0 source edge select bit T0SE. Clearing bit T0SE selects rising edge. Now I have a feeling that it probably defaults to 0 anyway. If we wanted to work on the falling edge, we would put T0SE to a value of 1 or set it. What I'm going to do then is I'm going to use that, and I'm going to count something that's coming in on the RA4 pin. I don't need to use an interrupt for this. That's something to be aware of. It's not that you actually have to have an interrupt and that's what actually increments the counter or anything like that. Instead, in this case, you just set up your counter. You can have an input coming into that pin, and later you can just come back and check what the value is. Now all we're going to do in the program is to check the counter value, so it's not like we're doing other things for the moment. So just remember, we had to set T0CS. We had to set that value, so put it to a value of 1. And just write a little comment beside these, putting timer 0 in counter mode. Now you might wonder, should we not call it counter 0 in this particular case? Generally speaking, it's known as timer 0 or timer 1, but it's in counter mode is the way we would put it, because we don't want the registers to get mixed up. Later on, we're going to be using the TMR0 register, which is clearly the timer 0 register, and but we're using it because it's in counter mode. We're using it as a counter. So we've done that, We don't need to set any interrupts or anything in this particular case because this is going to handle that on its own. And we don't actually need to we don't need to do anything with starting the counter off or anything like that for the moment. The other thing I'm going to do here is I'm going to set up port A. I just want the port or RA4, which would be a 10. Okay, I want to set that port pin up to be an input because obviously that's where the input to our counter is going to come. Just to show you in binary, that would be 0, 0, 0, 1, 0, 0, 0, 0. Okay, so we can clearly see this is RA4, this being RA0. Okay, so that's going to set RA4 as input. Okay, that's all we need to do there, if I remember correctly. And if it's not, we can come back and modify it later. Now, what I'm going to do in my main function is really relatively simple. I'm going to make an unsigned character. And I'm going to call it count. You've seen this before. And I'm going to initialize it to a value of 0. What I'm going to do then is I'm going to put count. I'm not going to increment the count value as such. What I'm going to do is I'm just constantly going to check what the value is in the TM or 0 register. Now this TM or 0 register is the one that you've seen before. We'll just check the document to see is it mentioned there. It should be mentioned. Yeah, when you can see a TM or 0, it's mentioned there. And we can see the TM or 0 register mentioned here. That's the actual detail that's going into it. I'll just see, does it say anything more on it? Using it as an external clock. So this is it. We can see it here, TMR 0, timer 0, module register. So it's the one that actually holds the value of it. So if it's a timer, that's the one, if you recall, you actually put the value into it to decide what you were going to count up from. In this case, TMR 0 is actually going to hold the current count. And what we should see when we run this program is that it should keep pace with the counting of the, it should keep pace with the rising edge occurring on RA4. Now, if you recall previously, I've shown you how to set up a stimulus input. So we're going to use that again here rather than be trying to do this manually. So I'm going to set RA4 as my pin. I'm going to set low initially. Again, so that I can kind of keep an eye on it so it's not happening too fast. I'm going to put 1,000,000 in here. If we were using a 4 megahertz crystal, that would be it would stay low for a second and high for a second. And again, I'm going to let that go from the start right until the program finishes. It says synchronous stimulus has been applied successfully. I'm just going to click that once. It's removed and then it's applied successfully again. I just want to make sure to do that because I've already tried this program already and it was applied already, but I cleared it, so I want to make sure that it's applied again and just be sure of that rather than being a bit unsure with what happens. So from that, I'm going to let the program build there, and what we're going to do is we're going to look at a watch window. I've made a mistake. And I think I've written TOCS, which is a very easy mistake to make, so be careful you don't do it yourself. It should be T0CS is what's there. And of course the O and the 0 look very similar, except that the 0 is a little bit thinner, so just keep an eye out for that one if you ever see it. So what I'm going to do is I'm going to look at the watch window here. I'm going to watch the value of count, and we're going to pause it every now and then just to check what the value is. So in my watch window here, you can see the value. I already have count set up, but if you don't, you can always set it up by just going into your main file and clicking on count, right mouse clicking on it, and add a new watch. Okay, I'm not going to bother doing that because I already have it done. It doesn't appear to be changing value, and that's because we need to pause it to see an update, and we can see this now at a value of 7. Now what I've also done is I'm looking at the TMR 0 register. We can see that that's also a value of 7. Now if I run it for another few seconds, just leave it running there and then pause, we can see that it's now gone up to a value of 9. So this is clearly counting the number of edges that are coming in here. And obviously, because they're coming in effectively, we can think of it as every 2 seconds, but remember your timing is a little bit out because all you're doing is you're running in a certain number of instruction cycles, and it depends how fast your simulator can run. This is quite a slow laptop that I do the recordings on here, so you may find that on your machine that the simulator is capable of running faster, and therefore you need to modify your values a little bit, or you may find you're running on a very slow, an even slower machine than this, in which case you may find that you can actually go for lower values so that it updates in a reasonable amount of time. Okay, so that's just the very first introduction to using a counter in MP Lab. Okay.